Four. All right. All right. All right. Test, test. Test. Test.
All right. Hello, everyone. Today we're going to be talking about exfiltration and using using exfiltration to get reverse shells, even in a whitelisted world.
So first, a little bit about us. We are graduated seniors from the Illinois Math and Science Academy, and we were on a project through an opportunity called Talent, which provides mentorship opportunities for high school students in STEM fields. So we were matched with Parker, and we were able to create this project and work on it through this school year this year. So a little bit about us, if you're more curious anyways.
I'm Matthew. This is John. We're both IMSA students, and we're both interested in hacking things.
So a little disclaimer, none of this actually exists. We're not presenting on anything. Bob did everything, and we're lazy, so we're gonna take all his credit. Like typical high school students, we're really good at copying work. Anyways, and if you record this, it's photoshopped. And what are terms of use? I never saw any of those. I mean, like YouTube, Twitter, sure, no. And then doesn't reflect any views of employers or schools because we go to school and yeah, college.
All right, so just a little bit about what exactly exfil is. So exfiltration is just getting data off a machine that isn't yours. And so if an attacker is getting access to a machine, and then they can quietly maintain that access, then it's pretty much game over. So they can get data off the machine, bring it back to themselves, and then do whatever they want with that data. And the most important thing is, though, that they keep quiet with that data. And because once they're noticed, then they can take actions against. So one solution that's started that enterprises have started using is whitelisting. So maybe that can save us. But so this is what today's enterprise looks like. Basically, they're all eggs. They're hard on the outside, but on the inside, you can basically do whatever you want. So once you crack through that outer layer of security, that hard outer shell, and you get to the inside, you can do whatever you want.
So has whitelisting made any of this effective? Because the strategy we were talking about is having everything blacklisted except for a couple types. And maybe whitelisting only sites that are harmless will make everything fine. We'll be protected on the inside, but no, that's not effective. It's really squishy in there, and we can do whatever we want, as we're about to show. And does DLP do anything? So we're already in the middle of this, and we can do whatever we want. We're going to show that this completely negates any kind of stuff you have on the inside of your protection. And does any security proxy really do anything? Like against this? Not really. So what is whitelisted? Typically, you're going to look at sites that are typical for use in a business. And also a lot of those are stuff that people want whitelisted. Like you want to go on Facebook. You want to go on social media like YouTube, Twitter, Reddit, even though your employer may not always want you on Reddit all the time, but it's going to be whitelisted because it's not a dangerous site. So do you think like Reddit, like worst can happen is you spend a lot of time on there. And also a lot of pages that are going to be whitelisted are like news stories, like Forbes, if you're trying to do research on stuff. Amazon's whitelisted a lot of times, and sometimes Amazon Web Service and Google Cloud, even though it might not be the best idea, that's a lot of times whitelisted as well. So what can we do with these whitelisted sites? So if we're trying to exfil data through these whitelisted sites, what do we need? And we need a page that we can write to, and a page that would be publicly available for us to download from. We can write to it, and then from our own machine, get that data that we wrote to it. And that is what we're building off of. So today, we're focusing on Twitter and YouTube, mainly because like Twitter is very popular. Like everyone here has Twitter. It's crowded, so not everything is going to be monitored, as we'll show a lot later too. And it's useful in a business setting. So for marketing, people use Twitter a lot. And because of that, it's going to be whitelisted on their networks a lot of times because that's something that they're using. And similarly for YouTube, you have a couple forms of output. You can do videos, comments, and crowded with a bunch of angry people that are all talking about different things, arguing, and really easy to hide stuff in there. And again, useful in business solutions because a lot of times people go on YouTube to look up stuff, try to solve problems, and you're not as a business going to pull that resource from your employees a lot of times. So it's going to be available for us to use in our Exfil toolkit. So some future channels are anything that fits the description I was talking about earlier with reading and writing to the page. So Facebook is a good one. LinkedIn, news sites, as I mentioned earlier, Reddit, all good stuff for us to be able to exfil data from. So first thing we started with, methods and processes, was for YouTube.
Yeah, so as John mentioned, we started out by looking at 2 different websites in order to kind of get a proof of concept going with our exfiltration. So our goal basically was to get comments posted on YouTube strictly using a program to do it, because that's how we would want to do it. Like if we load our payload onto a machine that we're attacking, then we want that machine to be able to execute our code and then post a comment with their data in it. So we started out like good developers would do, and we tried to use their API. But since we're doing stuff with like exfiltration and it's kind of sketchy, and like YouTube doesn't really want people doing this kind of thing with their website. And we discovered that through OAuth 2.0, which is basically the only way that YouTube wants you to access their website through programs. So OAuth 2.0 is annoying because it means that for every action that you want the program to do, like post a comment, post a video, make an account, subscribe to another channel, you have to have the user authenticated. They have to press a button, they have to type in their username and password, and then press grant access. And YouTube does this because they really only want people making comments. Now, this is a problem because we want our bots making comments and not people. So we need to find a way around this.
So our first way we looked at solving the problem was through scraping. We thought we could scrape the page and get like the login page, put in our data, and submit it using like JavaScript and send requests to YouTube to log ourselves in and post the comment. And we tried that, and we ran into a problem of obfuscated JavaScript because YouTube's got this big, nice block of obfuscated JavaScript that it's really, really confusing and hard to read with all these random methods and all this stuff that we really didn't want to have to deal with.
Yeah, so basically if you're just scraping the web page and you see this big block of JavaScript, there's not much you can do with it. So we tried using Python requests, and we tried using this thing called mechanized, which is like a nicer way to deal with scraping web pages, but neither of these actually deal with JavaScript. Like if you try intercepting the request for actually logging in, you'll find that there's this authentication token that it uses in order to get you logged in addition to sending the username and password, and this authentication token is generated by the JavaScript. So if you don't execute the JavaScript, you're not logging in and you're not posting any comments.
So we were just talking about mechanize and how we were going to plan on using that to solve the problem, but that also can't handle the disable button. So we thought, okay, if we can't run our own JavaScript, then why don't we just click the login button? After scraping the page, putting in our info, we can just click the login button and it'll generate all this stuff for us. It'll run the JavaScript on itself. But if you look at the YouTube login page, right as it loads, the JavaScript disables the login button for just a short amount of time. And that creates a big problem because as we scrape the page, the button while we're scraping isn't enabled, so we can't get that login button and click the button. So that was a big problem that we ran into trying to use the Mechanize as a solution to that problem.
Yeah, so then we found this really nice tool called DryScrape, which basically solved all our problems. So it's able to scrape web pages and evaluate the JavaScript for us. So basically, Google's like massive block of obfuscated JavaScript that they dynamically generate every time you load a new page is basically useless now because we can just evaluate it and then we can get the authentication token out of it and then we're good. So DryScript is really nice because it lets us do this and it lets us run our own JavaScript. But the built-in functions were kind of unreliable. Like DryScript has this click function which lets you click buttons on the page, but we found that this didn't always work and it seemed to rely on timings. So we kind of tried to set up like delays in the code, but that was kind of like a hackish way to do it and it was inconsistent. Seemed to depend on like network connectivity. So we found a better solution was to just write our own JavaScript and use this nice exec script function that DryScript provides. So our code basically ended up being mostly JavaScript and then some Python to actually run the JavaScript. And JavaScript's click always worked. And we were able to use that to click the login button on YouTube with our username and password, navigate to some video page, click the comment box because it makes you actually click the comment box in order for you to actually like send a comment. And then you press the send comment button and then it posts the comment. So then we're able to put whatever we want onto YouTube, and now we have this as a potential channel for our exfiltration.
Also, something that we should mention is that DryScrape is a great tool because it emulates the browser. So we can also, there's functions where you could take basically a screenshot of where the DryScrape is in the web page. So if we click a button and then we take a screenshot, we could see where that button took us, make sure we're on the right landing page. It made it really effective for debugging and making sure that we're getting to the right places and putting in the right data everywhere. And so DryScrape was by and far the best solution for YouTube. And then we decided to try our hand at Twitter.
Yeah, so Twitter, we looked at their API too, trying to be good guys, but we just found more OAuth 2.0, and we just decided to go with DryScrape again because that worked. But it turns out that DryScrape actually is overkill because if you try disabling JavaScript on your browser on Twitter, it'll actually redirect you to the mobile Twitter page. And so, m.twitter.com is mobile friendly, and thus it's also friendly to our bots because we can just write a request to the mobile Twitter page with our username and password, and then it'll just authenticate us, and then we can send another request to send a tweet. So this made our code way shorter. We didn't even have to use DryScrape. We can just use Python requests, and now we have Twitter available as another exfiltration channel that we can send data through. So this message is from Twitter, but the funny thing is, this didn't actually happen to us. This was actually a screenshot taken by a friend of mine who wasn't even using a bot. They weren't automating anything on their Twitter, but they got this message that their account's been locked because they were automating their tweets. But we never got this message, and we've been sending a lot of automated tweets and navigating through Twitter with our scripts. So whatever kind of protection Twitter has against this isn't stopping a couple of high school students.
Yeah, we've been working on this throughout this entire school year on Twitter, testing, debugging, running our scripts, posting the same exact comment like as a test every time, and we haven't gotten any of this. So I don't know what Twitter's looking for when it's looking for bot accounts, and if it can't find us, then I don't know what it's doing. And another example of it not being able to recognize something like this is this Twitter account called Password Turtle. It's at mkpassword. And what the little bio says is, I'm making passwords slowly. And what it does is it just generates, it seems to have post random strings of random characters at random different times. So some examples, random jumbles of characters, and this has no sense or anything. And obviously they haven't gotten caught for being a bot or anything. I don't know if they're actually using a bot, but it seems like very bottish behavior that is being implemented here. And here this has got this random meaningless text, and you could be hiding stuff there. That's what we could show, is that this could be used as an exfil. That could be where we're storing our credit card, and we're encoding our credit card data, some credit card data that we got from there. And then that's something we could pull and use as an exfil tool. So time for our demo. All right, so this is the Twitter account we're using to post our comment. And then from the command line, we're running our script to post hello CircleCityCon to our Twitter account.
So there's nothing here now. And then if we refresh, there you go.
There we go.
All right, and then we also have a demo of YouTube, but YouTube like just changed how it works. Like, this is another problem with not doing it through the API, is the fact that we're kind of like hard coding interactions with their website. So whenever they change their website, our code just breaks. So we have to like keep updating our code, or else it won't work anymore. And so that's what happened, and now we have to use a video to show how it's supposed to work.
So we're taking part of the URL that codes for this specific video, Hotline Bling, very popular, and using it as one of the parameters we pass our function, so that that's the video that our script posts to. And then we go to the comments. Now this all comments page is very interesting, because that's what we use to, that's the actual link we went to when we were in the script, and which was actually removed from YouTube recently, which caused the break in the code. So that this all comments page, where it's a page specifically dedicated to all the comments on a video, no longer exists. So we have to fix that. But there is our comment.
Okay, so then now we have our channels and our way to actually exfiltrate data, right? But there's a problem with this, because if we're just exfiltrating data in plain text, if we're just like taking someone's credit card number from their computer or something, and then we're posting it in a YouTube comment, it's probably not the best idea.
Yeah, a big part of this is the idea that we're gonna stay under stealth. We don't want to be recognized, because the second we get recognized, then they find the exploit what we were doing, and that's bad. So we want to make it so that no one realizes that we're in there, and we can, throughout this whole time, continue exfilling data and getting more and more. So we want to hide in plain sight. So where do people post dumb stuff? Social media, Facebook rants, Twitter rants, YouTube battles, like everyone gets angry all over the place. No one's paying attention, and it's just messy. And because of that, it's really easy to hide in there. So we hide as them. We hide as those people that are arguing with each other, the people that are drunk and posting on YouTube. And they could actually be drunk posting on YouTube, or they could not. And they could be the Exfil toolkit that we wrote that's posting on YouTube and getting your credit card data out of your business. You don't know. So that's the big part. You don't know whether or not it's our actual Exfil toolkit. You don't know what it is. And if humans can't tell the difference. And how do you program some automated proxy to know the difference? There's no way. You can't tell. And that's the beautiful part of this.
Yeah, so in this case, strangely enough, bad crypto is better than good crypto, because good crypto, they're going to be able to detect. They have systems already in place that can pick up on different types of cryptography that already exist, and then those algorithms also need entropy. But if you can't show that crypto to exist, then at that point, it doesn't really matter whether or not it's like easy to break or it's like a broken crypto system. And so the most important thing about crypto with exfiltration is making sure it's hidden. And then after that, make sure that that if it is found, do your best job at making sure that it can't be decrypted.
So the point that we made here is that good crypto, while in the end terms, if they find it, is good, because then you can't crack it ideally, but if they don't find it, then there's no problem. So the best would be to have bad crypto that they're not looking for, and then they don't find it. And if they don't find it, they can't solve it, and they can't see what we're doing.
Yeah, so if you want more details on this kind of thing, check out Parker's CypherCon talk at Iron Geek's website. So here's just another example of something that a machine probably wouldn't be able to pick up on, but you could still use it as a way to hide data. So these are two different phrases in Chinese, and see if you can spot the difference. But I'm not familiar with Chinese, but the first one means, do you miss me? And the second one means, I miss my mom. And they look very similar, but they mean two completely different things. And so a machine will have a lot of trouble picking up on something like this if you choose to hide messages in like Chinese grammar.
Another kind of thing you could do is drunk type stego, where you replace letters in a word that make you look like you're just drunk and stumbling over your keyboard, but you're actually using that to encode your data, your credit card information. So like drunk typing or hidden message, you can turn to drank typing or hidden message. And like you're stumbling over your keyboard, and that's what it looks like. If you're looking at it from the outside, it's like, oh, this is just drunk at his keyboard, great. And when we're actually getting data out of there, and that's amazing.
Yeah, just like checking, the way you would hide it would be like the characters that are incorrect or stumbled over, then you can use that to hide a message. But when a user is just seeing that comment, they just think it's some dumb person trying to say something. Another way, another kind of weird type of cryptography that wouldn't get picked up on too well is using white space. So you can use spaces and tabs and other white space characters, put that in a YouTube comment, put that in a Wikipedia page, make a Reddit post, and they're probably not going to pick up on that. But if you are looking for it, then you can find it, and then you can extract the data from it. So another interesting way to do this is using images. So with Twitter, you can post images on Twitter, and so you can actually get hidden messages inside of memes. And as we said, you don't really want to use commonly looked for crypto. So least significant bits is a bad idea, because that's the first thing you do if you're like doing like a CTF problem about steganography and you get an image, you're going to look for least significant bits. But everyone looks for that. So you need to like try something else. Basically anything, as long as it's not well known, not looked for, then people aren't even going to suspect it.
And plus you can take your own pictures. Like everyone has a smartphone. Just take a random picture, post it on Twitter, and that's a great way for you to hide all your data. You could have memes, you could have random pictures you took, like stuff where they are not looking.
Yeah, so basically going against everything you've ever been told about cryptography, you should roll your own crypto in this case. because sandboxing will catch crypto, but if you're manipulating the random bits, then the number of combinations is m choose n, so there's nothing they can really do. Yeah, so full control of the endpoints and no forensics risk, then you can embed the TLS and SSL, but otherwise don't do it. So now putting everything together and with an obligatory picture of a stereotypical hacker, we're going to use all this together and show how it can be used in real world. So what we've actually been working on with this and like what this is all a part of is the Glassdoor Exfil toolkit. And that's a project that we were working, that was originally started by Kyle Stone and Parker Schmidt. And so we kind of continued their work on this project. They gave a presentation about it at DerbyCon a while ago. And so we just combine everything we just talked about into one tool. We're trying to get things that we've been working on GitHub soon, and we'll get everything up there, and hopefully the tool will be working around DEF CON time. And so basically what it is it's a tool for exfiltrating data and doing things with that exfiltrated data. So the goal is to bypass this new security layer of whitelisting. And as we said, there's a lot of different channels you can do that with. So we use this tool to set up a link between the attacker and the machine that they're attacking, and then communicate between those two and send data from the machine back to the attacker and vice versa. And so we also have payload obfuscation is going to be built in, and that crypto is good crypto. And so the tool itself is modular. The modules are loaded in with a command line interface similar to Metasploit. So there's modules for channels, crypto algorithms, and payloads. So the channels are, as we talked about, like Twitter, YouTube, Reddit, all those sites are examples of channels. And then the crypto algorithms are like the white space and like just like simple test crypto, like Caesar ciphers. Basically anything. We're making it easy for anyone to basically just put in their own code for a crypto algorithm and set up their own module. So there's like endless possibilities with this. You can do it however you want in terms of this exfiltration. And then for payloads, that's things like setting up a reverse shell. And we've also included Stego in this along with the other crypto algorithms discussed. So now an example use case would be reverse shell by meme. So I'm basically going step by step through what the toolkit would do. So you load up the toolkit, and then you say you want the channel to use the Twitter module. So you're going to be sending through Twitter, and then you're using steganography with pictures through the crypto module, and then the payload is going to be a reverse shell. So every time you type a command into the reverse shell that it gives you, it's going to send a meme. And that meme is going to have your command in it, and then it's going to send it to the machine that you already have access to, and then that machine will execute the command, and then it'll send you the output of the command back. And when the output comes back, another meme is going to get tweeted. And inside that meme, the output is hidden. And then our toolkit will decrypt that and then give you the output. So it'll just look like you have a reverse shell, but behind the scenes, it's actually tweeting like 1 million memes.
Yeah, behind the scenes is all memes.
Yeah. And the thing is, there's not really much to suspect either, because there's a lot of these Twitter accounts that just like post endless memes. So yeah, there's nothing to see here.
And what guy wants to go through of the entire company, all the memes that are being posted during the day, all the images and all the random memes that are coming out of his company? He's not going to look through it all.
Yeah. So in conclusion, if you're on a network with web browsing, then you're still probably unsafe, because whitelisting doesn't really do anything. Because as long as there's these websites where you can post things you can get your own data on there and you can get your own data off of it, then you can set up whatever kind of communications you want. So DLP does nothing and can't learn security at RSA despite how much the vendors tell you you can. So yeah, we hope to get this tool released around DEF CON time and get a few more modules up and running with channels, crypto, and payload. And so we hope you guys check it out.
Yeah, thank you. So we want to thank a few people and organizations quickly. IMSA, our school, for providing us with the opportunity, as well as talent, the actual program this opportunity was conducted through, and actually got us to 1871 to meet with Parker every week. 1871, where we met with Parker to work on this every week. The head of the program, Jim Gary, Parker Schmidt, our mentor, and Kyle Stone for his involvement with the original GET project. And that's it. Thank you.
Any questions?
Thank you.